Namaste, welcome to the Pragna channel. You are watching Apache Spark Masterclass Beginners course, and we are in chapter 3, episode 5. I am forgetting every time before I'm ending each episode to remind you to do the quizzes, the interview questions, the classwork, and homework. So, if you are not doing that, I highly recommend you to do all of those, at least the classwork and homework, because we will be building on each video, so it's like a staircase. Okay, each episode's classwork, homework, if you don't do it, then it's like you are missing couple of steps. You cannot jump directly to the third or fourth step. You need to do step 1, step 2, step 3, step 4. That's how you will master the Spark. Got it? So if you are not doing it, I will highly recommend you to do it. Don't sit and just watch it. You will not learn anything. Only when you get your hands dirty by doing the classwork and homework, you will learn it. Trust me, if you do what I tell you to do, by the time you finish the course, you can you can land any job in Spark, whether it is Scala Spark, Python Spark, SQL Spark, Databricks Spark, Glue, doesn't matter. Anywhere you use Spark, you will be able to clear the interview, but you need to follow what I tell you to do. Okay, that being said, let's jump into episode 5 of chapter 3. Today we are taking a big step in our Apache Spark journey. If you ever wondered what's really happening under the hood when you write Spark code, or how Spark breaks down your commands into distributed jobs, stages, and tasks, this video is for you. I mentioned in episode 3, I guess, I showed you the Spark UI and I said I will explain these later on. Well, this is that video for you. We will go from key Spark application concepts all the way to writing and running your Spark application in both Python and Scala in this video. By the end, you will know how Spark actually executes your code across a cluster, and you will have real code to try yourself. So I am hoping you already installed Spark and everything, played with the Spark shell, and created the different applications in different ways that I showed you in the last 4 videos. Now it's time to understand how Spark works when you run your code. To do that, let's break down some essential Spark terms which I have covered in one of the video, but I keep on saying that I will cover these topics again and again, since you are new to all this. So when I mention these things multiple times, they will remind you of what it is and etc. So I will keep on doing it, and it will also help you for your interview. So what are essential Spark terms? Number 1 is application, which is a user program built on Spark using its APIs. It consists of driver program and one or more executors on the cluster. And then we have Spark session, which is your gateway to Spark. It's the object that lets you interact with all the underlying Spark functionality. In a Spark shell, the session is created for you automatically. It's called Spark by default. In a standalone app, like when you write an application in IntelliJ, you will create it yourself. And then you have job. Every time you run a Spark action like collect or save, Spark creates a parallel computation called a job, which is made up of multiple tasks. And then you have stage, which is nothing but Spark breaks each job down into smaller sets of tasks called stages. Each stage represents a set of operations that can be performed together, and the smallest unit of execution is task. Each task operates on a single partition of data and is executed by a core in the executor. Now, let's see how these pieces fit together. At the core of every Spark application is the driver program. This driver creates a Spark session object. If you are using the Spark shell, this session, which is spelled Spark, is created for you. And if you're writing a standalone app, you create the Spark session manually, which is what we are doing in our Zeppelin. When you run the Spark shell locally, everything happens in a single JVM on your laptop. But you can also launch the shell to connect to a cluster, and your jobs will run distributed across many machines, which is what in general happens when you work at a company, because they will have a cluster of machines. If you ever need help on how to connect the shell to a cluster, all you need to do is, if it is Spark shell, go here. We already have a Spark shell here. Let's exit out of this, and you can write, and it will show you different commands, and it will show you how to connect to the cluster, etc. And you can do the same thing for PySpark. It will show you. Let's look at a quick visual summary of how Spark distributes work. The driver talks to all executors across the cluster. Then you submit your code to the driver, as you can see here, and Spark figures out how to distribute the work. Now let's look at step by step what happens when you run a Spark action. Let's assume you wrote some code or at least a command in the Spark like collect and count. What happens? The driver, it converts your code into one or more Spark jobs. Each job is turned into a DAG, which is a directed acyclic graph, which I showed you previously. I can show you again. If only it is up and running. Let's see if it is up and running. Yeah, here we are 40. Okay. So I went to this job, and if you click on the DAG visualization, something like this, right? Spark, this DAG, as you can see here, this is a Spark's execution plan showing what steps needs to happen and in what order. Spark breaks each job down into one or more stages, something like this. So you have driver splits into job, then each job is split into multiple stages, which you can see here. We only have one stage here, but depending on the code, it splits into multiple stages. Some operations can be grouped together in one stage, others require shuffling data. So Spark splits them into separate stages. And once you have the stages, each stage is made up of tasks. A task is assigned to a partition of your data, and then each executor in your cluster runs multiple tasks in parallel. Okay. Now, basically, this is what happens behind the scenes. Imagine you have a cluster where each executor has 16 cores. That means 16 tasks can run in parallel per executor. So just, in your head, imagine about that. Here's where Spark gets interesting. Transformations, these create a new data frame from an existing one. Think of them as recipes, not results. For example, whenever you use select, filter, etc., group by, they don't run immediately because they are lazy, meaning Spark just records what needs to be done. Whereas actions actually trigger the computation. For example, when you run show, count, collect, save, when you call an action, Spark executes all the transformations that came before it. Right? That's why we call Spark does lazy evaluation, because it lets Spark optimize your code, rearrange or combine steps, skip unnecessary work, and recover from failures by replaying the transformations. What are some of the transformations? In an interview, they will ask you, what are some of the transformation commands? Well, just say select, which will be something that you will be using a lot. Filter, join, order by, group by. What about some examples of actions which we have seen? Show, count, collect. Then you have take, save. Let's see this in action, shall we? Do you remember the code we initially wrote where we read readme file? If you don't, that's fine. Let's go ahead and do it one more time. Okay. I hope you remember how to code by now, or code this by now. This is easy. Anyways, what do we need to do initially? From PySpark dot SQL import Spark session. Then we need to create our Spark session. Spark session dot builder dot. You can give the app name, but I'm not going to give it. Get or create. See the capitalization. O should be capital, C should be capital. Now we have our Spark session. Now we can write our code. I'm just going to say strings Spark read text. And where is it? It's in my slash home slash. I have it in my Spark home directory, which I don't remember the. Actually, let me. It's fine. It's fine. It should be in my home. In your Spark home directory, you should have the file. Read me dot md. Right? It's simple. We are just reading a text file. But let's filter it. This is the data frame. Let's use filter, or you can use where. What am I going to say? I'm going to say strings where the value contains, or value is my column name. If you don't give a column name while reading it, it by default puts value. I will explain it in a minute. Don't worry about it. Let's count it. Let's run it. 20. So what did we do here? You already know Spark read text reads a text file into a data frame, which is the strings. And the second line, it lazily filters rows containing Spark. What do you mean by lazily? Which means, let's say you ran after this line, nothing would have happened, nothing would have showed. Spark won't create jobs behind the scenes until you called an action, which is the count. This actually triggers the reading and filtering and counts the job rows, and behind the scenes it creates a job and all that. Okay, so this is what we wrote in PySpark. Let's try to do the same thing in Scala. In Scala, you don't have to create a Spark session, but I'm going to use a function called call column. So I'm importing all the functions, and then I'm saying val strings equals to, just to show how same they are, I'm going to copy this as is. Okay. And I'll copy this as is, but we need to tweak this a little bit. And what are we going to? You don't need to again mention strings. You will just say call though. You cannot just use the column name like that. You have to use the call function. Contains that, and then let's copy this. Okay, you got the answer 20. So in both these cases, nothing is actually done until we called count. That's lazy evaluation in action. Got it? And let's talk about optimization a little bit. Spark looks at your chain of transformations and decides the best way to execute them. Do you remember what are the two different types of transformations? Narrow and wide. Narrow transformations, each output partition depends on one input partition. That's it. For example, like the filter function we used here, or the map function, those are examples of narrow transformations where you have one partition. That's it. Your filter, it will apply, it needs data only from that partition. It doesn't need data from all the partitions combined for these narrow transformations. Whereas wide transformations, output partitions depend on multiple input partitions. So let me show you a figure, maybe that will help you a little bit. Where is this? This is not it. So this is an example of the transformation and action. So if you look at it here, this is a data frame, transformed it, data frame, transformed it, data frame, data frame, transformed it, data frame, but then you did an action. That's what it is showing. But what I wanted to show you is this one. This is narrow. So your file is on this partition. When you apply a narrow transformation, that's it. It will only apply on that partition and you will get the result. Same thing. But whereas when you do wide partitions, examples like group by, it needs this group by needs data from this partition, this partition, this partition, and it needs data from that. So that's how wide partitions happen. So as you can see, this is called shuffling. This is one to one. This is shuffling. Output partitions, they depend on multiple input partitions. This requires a shuffle across the network. These can be more expensive since data moves across the cluster. Okay. Just imagine in your head, make it a note like this: narrow transformations as everyone working independently, wide transformations as everyone needing to share their notes. Got it? Now, do you want to see how your job is running? Well, Spark gives you a built-in web UI, which is right here. Okay. From here, what can you do? You can view scheduler stages and tasks. You can check memory usage. You can see environment details. You can review all SQL queries. When you launch Spark Shell or even Zeppelin for that matter, look for the URL in the output. If you missed that, let me show you one more time. Oops. Okay, you can see the URL here, right here. Usually it's on 4040, but we are already using 4040. That's why it opened it on 4041. Okay. And you can even visualize the DAG as I showed here. Correct? You can see which stages are narrow or wide and how tasks are distributed from here. This is just an overview. We will go a deep dive into SparkUI in a later video, but it's a powerful tool for debugging and learning. Got it? Now, this is all fine. Now, let's put all these concepts together and build a real Spark program. Unlike whatever programs we have written, this is going to be a very big code. We will use a real data set, a file with over 100K rows, each with a state, M&M color and count. Okay, so our goal is to count and aggregate the number of M&Ms of each color for each state. Got it? So I'm going to copy paste the full code. It is a big code. So let me copy paste it and then I will explain you what it does. Don't worry about the code, just like our other videos in this particular chapter. This chapter is not meant to teach you the code. It is meant to show you how easy it is to create different applications and run them. Right. So I am going to paste the PySpark code first, and then we can go ahead and look at the Scala code later on. Got it? Okay. All right. So this is the Spark code. I know that we haven't seen one as big as this, but when I explain this, it is very simple. What are we doing? The first thing, we are importing as usual the Spark session so that we can create the Spark session, and we are importing a function which is the count, which we have done in other videos. Something this you might have not seen. All it is doing is checking for the right number of arguments. So this usually is executed in a Python script. I copy pasted it, but normally it is executed in a Python script and it expects um, two arguments from the script, which I will show you. I am putting this code here so that I won't forget to put it in the classwork again. Once it checks for the parameters, what are we doing? This we know. We are creating a Spark session. and then it is reading the argument to the command, and then it is putting that. So this particular Python script is going to get the file name that it is going to consume as a parameter or argument. It is going and putting it in here. Then using that, we are reading the file, and we already know this command: spark read format option header infer schema and load. Okay, schema inference is nothing but it is telling it to uh, get the schema from the file's header and assign. All right, that's what we are doing here. Then we are using high level data frame API, not RDDs. I don't think we will ever use RDDs unless and until it is the video where we are explaining about RDDs. We select the needed columns using the select, and then we group by state and color, and we aggregate count and we alias it, and then we order by it ascending, and then we are showing the results as you can see here, and then counting. We are using these two methods, which are actions that trigger all computation. Finally, we are filtering for California, which you can see here, and then we are aggregating and showing the top results. Okay, so let me do this. I will go and I will put this in a file, because this expects argument. I can run it here, but I need to tweak couple of things. Okay, do you want me to do that? Let's do this. I will put it in a file, trigger it from the file, and I will also come here and tweak this and run it from here. How about that? So let me go ahead and create a file using this code. Save this, and let's go ahead and save it in chapter 3 episode 5, and let's call this mnm count dot py. Save it. Okay, which is good. I don't know why this file is still here. Did I not save this? I thought I just saved it. Which one I saved it then? Huh? Okay, that's weird. M&M count dot py. Isn't that's what I did right just now? Okay, now it is saved, which we are good. So how do you run this script though? Well, using Spark submit. So let me control D. Okay. Now let's write the Spark command or Spark submit command somewhere. I am going to put it here. And by the way, we forgot to mention the PySpark. I always forget. So let me comment it here itself. The Spark submit command. Okay, let me copy this. So the Spark submit is going to, I'm going to execute this in the this particular directory, because this is where my script is. So let me open in terminal, paste. So we are telling Spark submit to execute the script and giving it a parameter, which is my file, data file that I wanted to process, but it is not in data. It is in data. Actually, I don't even need to give this, because the data file is in the same folder as this. So I think I'm fine with that. Enter. Spark submit command not found. Oh, never mind. I need to execute this so that my Spark variables are loaded. Now let's run this and let's look at the results once it is run. Okay, so it ran fine without any problem, right? So there are about what? Total 60 rows, which you can see here, where by color, by state, it will show you the M&M count. And this is something that we filtered on California, so it will only show California and color and this. So basically that's what this program does, right? When you run this code with the data set, you should see this output. You will see all the aggregations for every state and color, and then just for California. It's as simple as that. Now, how did we run this? We executed it using the Spark submit. So that is another way to execute it. And if you want to run it here, so let me delete all this. And I need to remove the space. So you know what? Let me cut it. I have my notepad plus plus. Okay, what? It's not copying it from here? Huh, interesting. Okay, I cannot do that there. Mm, mm. I thought I put two way, isn't it? Shared clipboard bidirectional. So why am I not able to paste it on the other side? That's weird. Okay, you know what? Let me edit it and I will come back. Okay, I did it. Let me paste it here. Let's hope there are no indentations issues. I just removed the spaces in the front. So let me run, we cannot run it yet because we need to give the file location here. And the file is in here. Okay. Anything else I need to change? I guess we are fine. Let me see. Let me run it. Okay. I think that's pretty much it. Even it did the total count at 60 and then it showed us the California. So this is another method to do it. Now let me go and bring the Scala code for this, respect to Scala code. And I will show you the difference between the Spark and Scala code and you will be like, wow, they look alike. Okay, but some steps will vary obviously, and you already know those variations. We have done those variations in other places. I mean, in other videos, we executed it, so you already know that. Okay, let me see. I'm editing the file. Just give me a minute. Okay, now just like Python, we are going to execute this from Spark submit first. Okay, so let me save this and let me say M&M count Scala. Yeah. Yeah, I think we should be good. Now, if you look at this, this is going to be chapter 3. So it's fine. Even if you don't package it, it's fine. It's just going to put the code in that package. You can import later. So we are importing Spark session. We are importing functions and we are creating an object M&M count. And same thing. Uh, we are creating the Spark session and it is checking for the input parameters and it is picking the file name from the argument 0 and then we are reading the file. If you look at this, it's the same, right? Format CSV, header true, info schema true, and then loading. It's the same as Python. And even this is same. We are selecting these 3 columns, grouping by, these 2 aggregating and order by. And then we are showing the results and then we are counting them and then we are filtering on California. Doesn't you doesn't this look exactly almost 80% similar to the Python code? Of course it does. So let's go ahead and instead of py, let's give it Scala. Will it run? It won't run. Why? Because it's not as simple as that. You might be like, we need to compile it into a jar and then we need to pass that jar to the Spark submit. That's how you can execute the Scala program. Correct? You need to build the standalone application or the Scala Spark app. In order to do that, what do you need? You need the build.sbt file. Correct? Do you remember, or are you like, I remember doing something like that? Well, yeah, we did it a while ago. So let me go ahead and create a build, and this is going to have a similar similar structure to what we had when we created it. So let me go there and get that. We had it in the, I don't remember where we had it. Did we had it the build file here? No, not here. Definitely not here. So maybe it's in the Spark folder. Ah, yeah, here. In here we had it. The build.spt open with text editor. So let's copy this and let's paste it in our new file. No need to do any changes except the name I'm going to give is chapter 3 episode 5 M&M count. Okay, so save this, and we are going to save it in here, and we are going to call it build.sbt, and that's how you should name it. Let's close this so that we don't confuse. Once you have this, what do you need to do? You need to go to this and be sure that you are in the same folder as the build, and make sure your Scala file is in there as well, and then run sbt package or sbt clean package, doesn't matter. Then it is going to prepare the jar by downloading all the dependencies for it, all the jar dependencies for it. Okay, done. Now go here, and what is the command you need to run to execute this from Spark submit? Give Spark submit, and then mention the class that you want to run from the file, and my class name is uh, M&M count. And then where is my jar? I think my jar is in the same folder. I guess that's where it got created. So if I go back, oh, it will be here. Never mind. Scala. Oh, here you go. So it's in target. What is its name? Okay, chapter 3. Okay, and then give the data set where it is, and it's in the same folder. So we are just going to say M&M. That's it. If the building jar building is fine, then this should give us our data that we are looking for. See, it's as simple as that, right? Now, what did you learn? Since Python doesn't need to be compiled by us, it does it on its own and it executes the code. But Java, Scala are not like that. You need to compile or build it, then you'll get a jar file, then give the jar file to the Spark submit and execute it. So you have to do all that drama. Now, let's go ahead and run the same thing, but from our, oops, from our zipline. So what am I doing is I'm removing all those spaces. So just give me a minute. Here I have it. Let me remove the output for this. Clear the output. Okay, here we go. This is going to be Scala, so just remove it, paste it. So this is the Scala code that I can run it here. It's, if you see, it's the same as, it's almost same. Right? If you compare it, it's almost the same. Now let's run this. We have the record, then count, then California. Right? It doesn't matter how you run it. If your code is correct, this Scala code does exactly what the Python version does. Reads data, groups, aggregates, sorts, print results. Spark's APIs are consistent across languages with small syntax differences. That's why my goal is to make you guys code in all languages Spark supports. All right. And there you have it. We demystified Spark's core concepts like driver, executor, jobs, stages, and tasks. You learned about lazy evaluation, transformations, actions. We saw the Spark UI in action and how to peek under the hood. Finally, we built and ran a real world Spark application in both Python and Scala. With Spark's high level APIs, you focus on what you want to do, not how to do it. Spark takes care of splitting, distributing, optimizing your code across a cluster. Now it's your turn. Try running the code from this video on your own laptop or Databricks if you set that up. Play with the dataset, filter for your own state, or change the aggregations. The best way to learn Spark is to get your hands dirty. And don't forget to do the quizzes, interview questions, classwork, homework. The links can be found in the description. Don't go to the next video without doing that. Got it? And also don't forget to like, comment, and subscribe for more interesting tutorial hands-on videos. If you got questions or want to see another Spark deep dive, let me know below. Thanks for watching. Happy sparking and see you in the next video. Peace out. Love you all.